We are looking at a graph with several critical points. There's one here, there's one there, one there, one there, and one there. So the question is, what is a critical point? Well, that's what we're going to take a look at today. We're going to define what a critical point is and how to find them. Okay, so here's some observations. It's points where the function could be changing direction. Now there's the key phrase there, could be, all right, not necessarily. Okay, so it could be going from increasing to decreasing or decreasing to increasing. Now, why did we say all that? Because at this point, you can see it went from down to up. At this point, it went from up to down or increasing to decreasing. Here, it went from down to up. Here, it went from up to down. And here, it went from down to up. Now, I want to be clear here. That might not always be the case for a critical point, but that is part of the definition of a critical point. We wanted to figure out what these points are. How could we do it? Here's some comments I got previously. Horizontal tangent lines. Very good. Well, if it's level, if the graph has a flat tangent line, there's a good chance it changes direction. Or the tangent line does not exist at all. So here we have a horizontal tangent, right? The tangent line would go like this. Here there would be no tangent line because it is a cusp, okay, or just pointy in general. And so that's great observations. These are two possibilities, and this leads us to the definition of what critical points are. Critical points are points where the derivative equals 0. This is the first part of the definition. There are two parts. So f prime of x equals 0. This is when a tangent line is horizontal. The second part of a critical point is critical points are points where the derivative does not exist. F prime of x does not exist. Now, that's twofold in and of itself. So either no tangent line at all or a vertical tangent line. So there you have it. A critical point is a twofold definition. It's where the derivative equals 0 or the derivative does not exist. You have to understand that a critical point has a two-part definition, okay? With that being said, let's go ahead and take a look at an example. Determine the critical points of f of x, where f of x equals x cubed minus 9x squared plus 24x minus 10. So here's our function, and we want to figure out what its critical points are. That is, where the derivative equals 0 or where the derivative does not exist. Let's take a look. All right. First thing here to do, since critical points involve the derivative, is take the derivative of the function. In this case, we will use the power rule. We become 3x squared minus 18x plus 24. The next thing you're going to do after you take the derivative is set it equal to 0, because part of the definition of a critical point is where it equals 0. So 3x squared minus 18x plus 24 equals 0. Okay, you can guess what we're going to do now. In order to have a critical point, you have to have a critical value. So step 3 is to solve for x. In order to solve this, we're going to have to factor it using the x method. You can also use the quadratic formula. I really should have pulled a 3 out to begin with, but anyways. A times c on top and b on bottom. Negative 6 times negative 12 is 72. Negative 6 plus negative 12 is negative 18. So then my expression will break down in those terms. Then we'll pull a GCF out here, a DCF out there. We're left with 3x minus 12 times x minus 2. Set each of these factors equal to 0. Add 12 divided by 3, x equals 4. Add 2, x equals 2. Now, I want you to understand this as well. You can have critical values and not necessarily critical points. Okay, in order for these to be points, I have to be able to plug them back into the original, and they have to give me a y value back. And you will find sometimes you will find a critical value, you'll plug it back into the original function, and it'll be undefined. In that case, it's just a critical value. It's not an actual critical point. So keep that in mind. Step 4, determine x values where the derivative does not exist. So this is the other part of the critical point definition. Now, for this equation, it's going to exist everywhere, right? This is a polynomial. We know the domain exists everywhere, and so we won't worry about that for this one. But for things like rational functions, square root functions, natural log, and stuff like that that have a limited domain, we need to keep an eye out for where the derivative does not exist, because that's also part of what a critical point is. Step 5, write out all of the critical values. Okay, so here's our two critical values just written out, x equals 2 and x equals 4. Like I said, in order for it to be a point, you have to plug it back into the original. Step 6, determine critical points. Plug the critical values back into the original function. Because we're talking about the graph of the original, those points exist on the original, not the derivative. Plugging a critical value back into the derivative would basically be finding where it equals 0, where it doesn't exist. Like, you'd either get 0 or undefined, right? So you have to plug it back into the original to find the critical point. So when we plug in 2 back into the original, we get 10. So my first critical point is 2, 10, and we're going to take a look at that in just a second to see what that looks like on the graph. The next critical point, we plug it back in, is 4, 6. Okay, so the next one is 4, 6. That's going to tell us our second critical value. And so once we found these 2 points, 2, 10 and 4, 6, we're done. I just want to take a look at the graph now to see what it looks like. Here's the graph of our original function that we were given. Okay, and right here, x cubed minus 9x squared plus 24x minus 10. We can see our first critical point, 2, 10. It changes direction here. Okay, and our second critical point, 4, 6. Now, real definition is it has a horizontal tangent line. That means it's a critical value. Okay, but a lot of times, like we said, a horizontal tangent line means the graph changes direction. Not always, but a lot of times. Taking critical point 4, 6. That's it for the first example of critical points. If you have any other questions about this, let me know.